Welcome back. This is part 2 of the how to create an augmented reality game for your iPhone in Unity 3D. Today we're going to be going through the basics of Unity scripting, and it should give you a really good jumping off point to start developing your own stuff in Unity without all the confusion that most people have to go through when they're getting started. So, since we're talking about scripting today, the first thing we're going to do is create a new script. So we right-click or two-finger click on the Mac and create a C# script. Now you can see it says New Behavior Script. That is going to be the name of the class that is created in this C# file. So I'm going to go ahead and change this to Move Around. Okay, you can see over here I get a little preview and it says public class move around. It just took the name. Now if you do update the name of this file, it will not update the name of the class. So if you want to change the name of the class, you have to go and change it in the source code and then change the name of the file. So we are going to try to keep our project tidy. So we're going to go ahead and make a scripts folder. We're going to drag this in there. Now I'm going to want to move around my cube. So let's just remove that. So I can go about that two ways. I can click Add Component, and that will bring up this, and I can type in the name of my class, move around, and that will add it. Or I'm two-finger clicking here, and I can remove component, and then I can also just drag it in from the project panel, and there it is. So now we're gonna edit this. Alright, Visual Studio's opening. Hopefully everything will open up just fine. It can be a little crashy here, but everything looks good. Now you'll notice I have a big square funny looking cursor, and that's because I'm in Vim mode. And if you don't know what Vim is, go ahead and look it up. The people like me love to use it, and then we love to talk about using it. So I'm not going to bore you right now. That could be a whole nother video. Alright, now you see it created two functions for us, start and update. I'm going to get into those, but there are a few other functions that are a lot like start and update that you should also know. Okay, these 6 functions are probably the most important functions that you will run into in Unity. Now they do all require you to inherit from MonoBehaviour. MonoBehaviour is like Unity's general purpose parent class. It contains everything that kind of a class needs to work with a Unity object in a scene. So it basically gives you these functions for free, and you can feel free to use them. We'll talk later about dealing with performance in LateUpdate, and FixedUpdate, but for right now, don't worry about it. Basically, the first function is awake, and it is the first function that gets called when your object starts up. So in that you can do stuff that you want the object to do before it exists on the screen. So maybe I would do transform.position equals new vector 3 100 0 0. Okay. So let's see what that does. So there's my object. We're gonna look at it. So its position is 0.29, 0.37, and minus 0.46. Very, very random values I gave it. Oh, it's gone. Let's take a look. Let's find it. Well, check it out. It's way out there in the middle of nowhere. So our game can't see it, but when you turn off play mode, then it comes right back to where it was. So that's an important thing to know. Everything that you do to anything in play mode just happens in play mode. You don't have to worry about it affecting your initial setup. So, for example, I can move this all around. So there it is. It's minus 18.6 now, and then I'm gonna hit play, and there it goes. It moves it to 100. So we're just gonna undo. There we go. So I can see it. Oops. That is an HTTP server that I'm running for other projects. Hey! So now let's take a look. If I move this code into here, then same effect. Now, if you're in something precision, you would have noticed that it happened slightly after it would have happened before, because it's in start, and start comes after awake. So now, update. Update is kind of the workhorse of Unity. So we're gonna do something here. We're gonna take transform.position.x plus 0.1. Okay, so basically, like it says, update is called once per frame. So we're gonna this is something that will drive you crazy in Unity, because C# defaults to double as its decimal representation, and Unity likes to use floats. You have to pretty much on all your literals put F. So it's just one of those things. So let's look through this code. Every frame, this is going to be called. So what it's going to do is basically it's going to update the position of the object and move it 0.1 to the right. I think it's right. Let's see. All right, let's go. Oh, there it goes. Bye. Excellent. Now, that is, as you can see, update is where you put stuff that you need to have happen over and over again. In classical parlance, we would say that is the game loop. And I tend to treat it as a game loop and try to only have a few update functions going. So, now, late update. Basically, late update happens at the end of the update cycle. It's right near the end of the frame, and so if you want to do something quick that's related to rendering, then late update's a real good call, because by the time late update's called, all the updates have fired. So if we do the same code, it will behave exactly the same. That's good. Now the last one is FixedUpdate. FixedUpdate Oops. See, now this is the problem with Visual Studio. It just totally ate my undo history. That's fine. FixedUpdate brings us into a new concept that is time, and in particular delta time. Whoa, check it out. Here we go. Time dot delta time. So delta time is updates time, and basically that is the amount of time that is elapsed between this frame and the last frame. Now, why do I need to know that? Well, let's say you are moving a character around. You want that character to move smoothly. Now, since update is not guaranteed to call in exactly the same amount of time each frame, you need to use time delta time to figure out how much you need to actually use it. So a good thing to do in this would be to debug.log time.delta time. So let's take a look. And we're going to hit play. Now we're going to go to the console, and that's plenty. Now you can see that it's always somewhere around 0.016, but it is never the same. It's always slightly different. And those slight differences can make a big difference. I mean, you look at that, that's almost twice as long as some of these other frames are taking. And if you're moving a character around, especially in a nicely animated game, and you assume that it will be somewhere around 0.016, then you're going to get some really ugly looking stuff. So in the next video we'll go into that, but before we do that, we're going to go ahead and log out time dot fixed delta time. So, of course, we really want to put this in FixedUpdate, even though it doesn't matter, and I'll show you why it doesn't matter. Let's hit it. Oh, check it out, 0.167. It's always the same. Now that sounds great, right? So FixedUpdate for everything. The problem with FixedUpdate is that since it always fires at exactly the same interval, it will sometimes miss frames. FixedUpdate is ideal for physics, where you really don't want to do all the extra math associated with a fluctuating delta time. And you can handle being off by a frame or two. And update is really, really good for moving a camera or moving a character. So that's all we're going to cover right now. Next time we're going to get into user interaction and actually let you control this this cube. Thanks, and remember to subscribe and hit the bell for notifications. This is Right Lane, signing off till next time.